In this video, I wanted to do some more examples of simplifying radicals. And there's a little step-by-step instruction guide on the packet if this is something that's been challenging for you to do in the past, or if you've never really seen this before. But basically, if you're not really sure where to begin and you want a more of a systematic approach, you can follow this sort of steps. And let's practice doing this a few times. So what it says, step 1 is to completely factor the radicand. Basically, you could build a factor tree and see what are all the factors within there. And then it says step 2, depending on the index, which remember is the little number, whether it's a square root or cube root or whatnot, look for repeated factors. So it says for square roots, look for factor pairs. For cube roots, look for trios. For fourth roots, look for fours. But basically, once you've found the complete factorization, we want to see, is there a perfect square or a perfect cube or whatever within this number? If there's not, it will not simplify. It says split the radical up into pieces, putting all the repeated factors into one and non-repeating into the others. Simplify the piece with the repeated factors, basically by just taking the root. So let's look at a few examples. So say this square root of 28, and you could start by just factoring the number. But let's just say, let's try to follow this step-by-step process. So 28, if I build a factor tree, could be broken down as 2 times 14, and 14 is 7 times 2. And once we've broken it down into all of its prime factors, that's that, and we're done. And so once we've seen the prime factorization of the number 28, basically, if I look for factor pairs, there is a pair 2. Now that is what you want to split apart from the 7. So basically, I could rewrite 28 as square root of 7, or square root of 4 times the square root of 7, because 28 is 4 times 7. And notice that the pair I've kept together within the square root. And of course, the square root of 4, because that's a pair, is 2. And so square root of 28 will make 2 root 7. Moving on to a slightly more complicated one, like 700, or bigger and bigger numbers. Again, I could start by factoring the number 700. 700 factors as, well, I could do 100 times 7. And even at the point where you recognize a perfect square, that's kind of the shortcut, is instead of completely factoring it, well, 100, that's just 10 if I take the square root. And that's, how you could do it without following the procedure. But if you keep going, well, 100 is 2 times 50. 50 is 10 times 5, and then 10 is 2 times 5. And if we do fully factor the number into its prime factorization, again, looking for pairs, I notice that 2 is a pair, 5 is a pair. What that leaves me with is 7. So that's how I want to factor it, as 100 times 7. Since the 100 is comprised of 10 times 10, or 5 times 2 times 5 times 2. And then, of course, this would be 10 root 7. Now let's try doing it for higher index numbers, such as cube roots or fourth roots, or so on. Say, for example, I wanted to do the cube root of 54. Again, I could start with a factor tree, which 54 is 2 times 27. And at this point, I could recognize, well, 27 is a perfect cubed. It is 3 cubed. But I could always keep going. That's 9 times 3, and 9 is 3 times 3. So ultimately, what I'm looking for with a cube root is a perfect trio, or perfect cube, which is indeed 27. So basically, I would have 27 times 2. I could split it up as the cube root of 27 times the cube root of 2. And the cube root of 27 is just 3. And this would leave me with 3 times the cube root of 2. And you might be wondering, can a calculator do this? Yes, some calculators do simplify radicals and some don't. It kind of just depends on how your calculator works. And it usually takes a fairly advanced calculator to be able to do this. And let's also do let's do a fourth root as well, just for the sake of why not. Let's say we wanted to simplify the fourth root of 1120. Well, again, I think it would be prudent to start by factoring the number 1120. That's 10 times 112. And 112 is 2 times 56. 10 is, of course, 5 times 2. 56 is 2 times 28. 28 is 4 times 7. And 4 is 2 times 2. So we want to make sure to factor it into its prime factorization. This number is quite large, has a lot of factors, but again, with fourth root, I'm looking for perfect fourth. So notice that I do have 4 2's within there. So that would make 16. So I could split this as the fourth root of 16 times, and then whatever's left is not in fourth. So 5, 2, and 7, which would be 70. So 1120 factors as 16 times 70. I could then split this up as the fourth root of 16 times the fourth root of 70. And again, I know that the fourth root of 70 will not simplify because 70 doesn't have 4 of anything. But 16 is 4 twos, so that would be 2 times the fourth root of 70.